the rough compute.
The rough compute. Okay, yeah. I think that's a pretty good one.
Maybe, yeah.
Yeah.
So, I guess I should do an intro or something.
Yeah. Like, do we need the jingle? Da-da-da-da.
That's it now. So with me is Arlen Brower, and I am David Cooper. Almost got my name wrong.
That would be a good start, yeah.
Yep. And what I'd like to talk to you about is the subject of live coding demos. So you've done a bit of lecturing in your time,
Yes.
and you've done a bit of live coding demoing in your time.
Yes.
So I know you're quite passionate about this,
Yep.
and I'd like to get your opinion on why do you do it,
Okay.
to start with.
Yeah. So I think part of it came about from like trying to explain really tricky concepts like pointers in C. And it's one of those things that if you just put up a lecture slide and say, here, have a look at this, nobody is going to understand what's happening. Even though in this case you're the one who actually made those lecture slides I'm talking about.
Oh no.
There's only so much that just the visual side of things can do. So my initial impetus for it was to show students what's actually happening, play around with it, make some changes, see what changes, like what that changes in the output, so that they can see, blow by blow what's actually happening.
Yeah, so this is obviously in C coding, and is it the movement, or is there another depth of information going on there?
So I think for one, there's also I think the initial thing is that there's some good engagement from, okay, it's not just somebody who's standing up there talking away nonstop. That you're actually doing stuff that they are themselves going to be doing. And I think even that right there is probably a big part of the connection. It's what they are expected to do. You're showing them, you're walking them through that. And I think that helps elevate kind of that retention.
So they can see what they're going to be doing in the future, rather than just trying to extrapolate from the fixed lecture slide.
Yeah, and then you also have a very fast feedback loop with that, because like I said, I like to make changes. Okay, here's what happens if we do this. If I make a change to the code here, here's what happens now. And I can pause and say, can anybody guess what's going to happen next? Will this compile? Will this fail? Will this work as expected? And get people to try to engage like that as well.
That's an interesting point, the feedback cycle, because the feedback cycle is a large part of what's special to me about computing education, I think, because you in the labs you can get this fairly quick feedback cycle. Of course, you're on your own though, but in the lecture, it sounds like a live demo gives you the same experience, but in a more guided way. So you get both that feedback from the actual process unfolding in front of you, as well as the lecturer's expertise.
Yeah, absolutely. I think I'm always trying to find ways of getting that quicker and quicker feedback to students, and that's a really good one. There's another side to the live coding that I think is really important, and I didn't realize this at first, and that's when it fails.
Oh, yes.
So when it actually fails, students can see, for one, that I can make mistakes. I've been doing this for, 20-ish, 25 years, and I will make mistakes. So they shouldn't feel bad if they make mistakes. But what's also really interesting is how I go about the debugging process, because I think that's one of those things that you can't really teach by just lecturing. Like, you can't say, you guys need to fix your code.
That's an interesting point. It takes a bit of courage to do live debugging. Live coding, live demos are one thing, but actually trying to go through the diagnostic process yourself in front of a whole pile of people.
Yes.
When you don't actually know, obviously you don't actually know at the start what's
Yeah.
the outcome's going to be.
I mean, there are some things like, okay, I forgot a semicolon, no problem. But especially when you get into, tricky concepts like pointers with C. But I suppose it can really be anything when it comes to coding. But, like you said, you don't know what's happening. You don't know what's going on. But just that ability to say, okay, I'm looking at, these are kind of like the things that I'm seeing from the code. That leads me to believe that this area here is the problem, and therefore maybe it's this. So talking them through that process can, I think, really help show them what's that.
That's an interesting point, because the debugging process is all about this. Again, the feedback cycle of hypothesis forming and testing, and you can see what the evidence is afterwards. That was part of what I learned in my PhD. I think is the way that we understand code is through the cyclic hypothesis forming, testing, searching process, and I guess there's value in as you say, there's value in the students being able to see you go through it and being able to imagine themselves in that process as well, because it can get a bit. I feel like it can get a bit scary for students when they assume that they should be able to get it right the first time, and they're not used to this idea, or they're not comfortable with this idea that it's iterative.
Yeah. It's not just one. You hit compile and it's going to work, or it's not going to work. You have to work through it. And even if it does compile, you still have to find out, does it actually do what you think it's going to do?
Exactly.
Generally speaking, though, it tends to work out, especially, like I said, I've been doing it for quite a long time, so I usually know, especially in that kind of small-scale demo code, what could possibly go wrong. So it's not like I'm going at it completely blind. There's only been a few rare cases where I've had to go, okay, this is taking too long. I'll come back to this, and normally what I'll do is I'll do a little announcement afterwards to say what the problem was, so that people get a little bit of closure, but it's also really my own closure, because I'll go away going, what was actually the problem?
That's good, I guess. I guess in the general sense, if people are doing this, then they need to establish a point at which they stop trying to fix it and just have to move on. Not ideal.
I guess that's possibly also a good lesson learned there.
Because you don't want to be dragging it out through tens of minutes or the entire rest of it. I remember, I don't do enough demos probably, but I remember one that I often do when I'm teaching multi-threading and trying to demonstrate what a race condition looks like, and getting these results where I couldn't get the race condition.
Yes. I've had that exact same thing where I could get the race condition on my laptop to happen pretty much every single time, and I was like, yeah, perfect, I've got it. I go to a lab machine and it's no issue.
Why are you working? You shouldn't be working. So. We covered most of the questions that I had without me having to ask them, actually. Except for you discovered a way of using generative AI, I guess, in connection with live coding demos, I think.
So I think it comes about not having prepared for all the questions that people could possibly handle. So that's my phone there.
Oh, good.
So somebody might ask a question that I don't have a bit of code ready to go.
Right. So in a live Q&A kind of environment.
And for something like fundamental C programming, I can usually fire up something really quickly, no problem. But for doing something more complex, such as talking about object-oriented software patterns, those can be more complex examples, and if I don't have something, I can't just spend 15, 30 minutes creating a simple example.
They do take some creative effort, and just the coming up with the context for how you want to present this idea.
Exactly.
Yeah.
And I think that's what I've found a good use case for Gen AI with that is to basically say, okay, I want you to give me an example of whatever it might be, the composite pattern.
Yeah.
Show me, give me something simple there and say, okay, here's what we've got, and if we look, this is, the way that it's generally structured, how it actually looks in code, and we can, potentially change things around. Or another really nice one was actually, I think it was for the observer pattern, showing a GUI. Like, make a simple GUI application that will, show this pattern. Because it's a great way of, showing off how these different components are interacting. But I don't have the time. I don't even have like the spare time to make a GUI program for most of these things. So just being able to say, do that right now, boom, done.
Yeah, I mean, definitely, it's often tricky enough to come up with prepared examples, but if you're trying to do this at a larger scale in a quick one-on-one or as kind of requested situation, then you need something quick, and that's an interesting use. I'm not generally a big pro Gen AI person, but I can see the value in that, and particularly because obviously there's a person there with all the expertise who can ensure the AI is not doing silly things.
And there's another aspect to that I think is great from an educational point of view, which is we're starting to see more and more that employers want students to know how to use AI.
That's an interesting point.
So if
you can demonstrate that.
I can demonstrate a good use case of, I already know what this should look like.
Yeah.
I can go through, I can quickly verify that looks about right, and I can make tweaks as I need to. So I can kind of go through a quick life cycle of using Gen AI for those kinds of purposes.
So what, in that situation, would you use an IDE to do that, or just a text editor, and you just ask ChatGPT or something to give you the code?
I think in an ideal case, you would probably have some kind of IDE with a some kind of plugin integrated in that you just put in a prompt and boom, it edits the code for you, and you have everything kind of very streamlined. I've just been using Vim.
Yeah, so, fair enough. We all love Vim.
So it's just, I go to the website, here's the prompt, copy, paste, done.
Right. Yes. Do you find that it needs to be corrected much?
Depends. For simple examples, and I find in the case of things like software patterns, it pretty much knows what those things should look like. It's a very well-defined space. I think it can give me a good example of whatever pattern I ask it to bring out. Simple things like any kind of fundamental C programs I might come up with. It can also do those pretty easily. For more complex things, such as constraint satisfaction problems for scheduling, say staff in workshops, it takes me 2 tries.
Okay, that's still pretty good.
So it's gotten a lot better. Scarily so.
Getting back to the more basic approach to it, I guess. What would be your approach to preparing in advance of a demo?
So it depends on sort of how in-depth I want to go. If I'm going to create a system beforehand that I want to demonstrate particular concepts, especially if I can kind of bake in failures that I know are going to fail and go through that process of how do we fix that, that's always something that I look for. Like, what kind of basic template for the code can I create? And then what tweaks can I put into that code to demonstrate some kind of learning outcome, whether that's debugging or scaling up the code in some way. For example, with something like function pointers, I might say, here's a very simple way of doing this program that doesn't really help us. If I start to compartmentalize it, so for function pointers, I actually have 3 different programs that I created, so I could kind of show, here's the simple level, let's go one level above, that's looking better, but we could improve it even further. So I'll try to think of the learning outcomes that I want to target, I think. Is probably the way that I tend to go about it.
Would you have a complete set of code before you go into the demo, or would you just have a more general idea of what the code should approximately look like?
So it will depend. For something like that function pointer example, definitely want to have something already there that I can delve into without having to spend the time creating all of this stuff. So I think it really depends on if I think there's value in having me do it from scratch. And I think especially at in a first year level, there really is. Because many people are going to get lost if you just kind of jump right into something.
Yes.
So taking it from scratch and saying, okay, I'm going to do this, I'm going to do that, and quickly building it up.
Do you have the code in advance though, even for your own purposes, so that even if you don't show it to them, you
typically
yes.
Yeah. So usually to say, okay, will this concept that I have in my head actually work out?
Oh yes, you need to go through the feedback cycle yourself first, I guess.
For demonstrating, say, servers in functional programming like Elixir, that's another one where I can do it really quickly if I practice it. So there is even a little bit of practice beforehand of, okay, what do I need? What are the steps that I need to do to create a server and do these things and make a connection between 2 different processes.
I guess it does come down to our own learning curve and our own practice in doing that. I might leave it there if you're happy.
I think that sounds good.
Well, thank you very much.
My pleasure.
And we'll try and do this more often, I guess.
Yes. I always like talking about these things.
Excellent.
All right.
And
that's that.
That is that. Yeah. So with me, how do I do this? I'm gonna get it wrong now. I'm actually trying to do it properly. I have to think about how I introduce us.
Yes. Do we have a name?
Yeah. Well, that was the other thing.
Call it Underneath the Broken Fitting.
Underneath the broken. I mean, it's not inaccurate. Anyway.
Yeah, I'm all for names.
Yeah.
If there's one thing that I actually really use ChatGPT for, it's finding names.
That's not a bad use.
I just say, give me a name. Give me a whole list of names. No, change the vibe.
Change, yes. Revive my names.
Exactly.